a way to take the real world data and make it visual for easier understanding. But what if they aren't? This is a graph that was actually put out by an American company about how their product was better than its competitors. There is nothing factually inaccurate about this graph. However, this is what it should look like. Graphs have been used commonly throughout everything. For me, as a math teacher, the graph on the left is way better than the graph on the right. But there's nothing wrong. The graph on the right benefits the company, the graph on the left benefits the consumer. People use graphs to their advantage. Slow reveal graphs is a way to demystify graphs so that what happened in that advertisement before will never happen to our kiddos. Slow reveal graphs is a way to promote sense-making, talking about data from the real world or in mathematics or science. The website, slowrevealedgraphs.com, is the source where you can get some of these ideas on how to make it and some ready-made ones too. But we're going to talk about what it is right now. The design that I like to use for slow reveal graphs has a 4-step plan. Step 1, display only the graph, hide units and labels. Step 2, display only the graph and units, hide the axes, labels, and graph title. Step 3, add the graph title and labels. And step 4, display graph and the scenario. The goal of the slow reveal graph is that each step, students in either groups synchronously or independently asynchronously are able to talk and make judgments based on the information that's presented to them. The goal, simply put, is that when they're presented with an entire graph, they are good consumers of the graph to look for any biases that might naturally appear. In the article, Impact of Metacognitive Strategies and Self-Regulating Processes of Solving Math Word Problems, I came across this little strand of information. What creates gaps in the processes of solving math word problems is precisely the failure to take into consideration the reciprocal relations in cognitive processes between reading and mathematics. Nowhere is this more evident than in graphs, where we now have an opportunity to mislead readers of the graph without actually lying. Now I want to go ahead and be very, very clear. We are going to talk about ways to use correct information to mislead readers of graphs. These are 5 ways that writers can use to massage the numbers to make it work. The first thing is omitting the baseline, starting at a number other than 0 in your y-axis. The second is manipulating the y-axis to make the y-axis far larger than it needs to be in order to de-emphasize the change. The third is cherry-picking data, picking particular data points that make your point look stronger than it really needs to be. The fourth, using the wrong graph type. In this example, they used a pie graph to show false equivalency where a bar graph would have been far more appropriate. And the last is going against conventions. By picking different color schemes from what you normally expect, it throws off or skews how the reader reads the data. In making a slow reveal graph problem, we basically follow a simple plan. Now, for me, I use Google Slides for the synchronous version, and I use Desmos Activity Builder for the asynchronous version, quite frankly, because it's simple and it's free and it fits my budget scheme. The recipe for this: pick a problem that you want to use graphically. Screen capture it, put it on a Google slide. Use the crop feature in the Google slide to trim down to the part you want. Duplicate the slide, and then using the crop feature again, we expand. Repeat those steps over until you get everything that you want for the problem. Let me show you. Here's a problem I'm going to use from the 2016 6th grade STAR test. The whole problem is there. The multiple choices is at the bottom. The graph, the question stem, and the pertinent information on top. So here's how I would take this image and remake it to make my numberless word problem. First of all, go ahead and go into the editing thing. I'm going to go ahead first. I'm going to click on the image. I'm going to crop the image down to just the picture. Remove all the labels, remove all the units of measure, remove the title, And because I like symmetry, I'm going to go ahead and move the right-hand boundary as well just to make it look good. Enter, make it bigger. This is the first slide, just the graph. Go here, right-click on the slide, duplicate it. Now, go back, click on the image, go back to crop, and then I do the next step, which is to show the units of measure. Again, no context, just units of measure. Now, in the first step, we would have asked the students to go ahead and make a story. The second step, we're going to now ask them to take the new information and refine your story. Duplicate it again. And now we go back to the crop feature, add the labels, and the title. So now there's context. This would be the step where we say, okay, now we have a lot of information here. What does this story say? Again, predicting what the background information is going to be. Duplicate the slide, go to the next one, and now this is the part where we get a little bit more nuanced. I want to add in the question stem. So I'm going to go ahead and crop it. I'm going to expand the window on this so that I can get in the questions, not the question stem, excuse me. I'm going to add in the background information. I want to go ahead and have all of this together because this is the part where I say predict a question I could ask. And then we give them the whole thing. This is the plan for the slow reveal graph design. Step 1, display only the graph. Hide the units and labels. The reason was we want students to make a story about what they see. Step 2, display only the graph and units. Keep hidden the axes, labels, and graph title because we're going to ask students to refine their story based on the new information. Step 3, add a graph title and labels to the picture. Ask the students to make a new story to fit the graph title and all the new information. And step 4, display the graph and the given scenario because we're going to ask students to create their own problems that would fit the scenario and graph data presented. This is the basic plan to create your own slow reveal graphs for your students.